Calculation of relative atomic mass using relative isotopic masses. Now keep in mind the relative atomic mass takes into account the masses of the isotopes. The mass of the isotope is a simplified term and we refer to it in chemistry as relative isotopic masses. Now, how do we calculate AR, which is our relative atomic mass? It is the sum of the relative isotopic mass for each isotope multiplied by the natural abundance of that isotope in, of course, nature. Now, let's say you're given this information. So we have two isotopes, and the isotopes are referred to by their mass numbers. However, remember that the mass number refers to the number of protons and neutrons in the atom, and it is approximated to a whole number. The isotopic mass gives us the real mass of one atom of an isotope as compared to the standard reference of 1/12 the mass of one atom of carbon-12. We are also given the abundance of each isotope in nature. That is, in a sample of, let's say, 100 atoms, the percentage abundance of each isotope would be 75.77 and 24.23. Now, abundance, as seen here, is a percentage and should add up to 100%, but there has been at least one CAPE question where the abundance did not add up to 100%. We will look at that question later on. For now, let us calculate AR, which is relative atomic mass. So we are going to multiply the relative isotopic mass of the chlorine 35 isotope by its abundance. We're going to add that to the relative isotopic mass of the chlorine 37 isotope by its abundance. It is all divided over the number 100, and this is where we use the percentage as a whole number versus moving that decimal point to give us the fraction. Right, so in order to calculate the relative atomic mass, you're taking the abundance as the percentage given and you divide over total abundance, which should add up to 100%. And our answer is given to us to three significant figures. So 35.453 is the real relative atomic mass of chlorine, and in the periodic table, it is merely rounded up for aesthetics. You ought to note, once that term relative is used, for example, relative mass, charge, atomic mass, isotopic mass, no unit is assigned to that number. If you do put a unit, let's say grams next to it, a mark will be deducted.